Okay, so let's get going and understand people have to drop off for a midterm. So whenever you feel you have to, it's all recorded. So feel free. Okay, so we're talking about graphics. So there are three types of graphics functions in, well, most graphics libraries, including EasyGL. So the first set of calls are to set up a graphics window. So you just do that once, and it's basically getting your piece of paper. So you're getting ready to draw. And you look at the EasyGL example program to see how do I set up a graphics window. Then you have calls to set drawing attributes, and you're going to call those many times as you're drawing. Okay, so those are basically choosing what pen or what paint color, what pen thickness. That's what you'd be doing if this was on a piece of paper. You have calls to draw primitives, and again, call these many times. So lines, arcs, polygons, rectangles, images. So images are, like PNG files, so bitmapped images that you can load in and paste on your display all over the place. And you have to respond to user input. You're going to do that many times as well. Okay, so whenever the window is resized, the view changes, you have to redraw the display. The graphics library doesn't know how to do it. So there are graphics functions that allow you to respond to user input. Okay, so how are we going to respond to user input? And let me just move this window out of my way. So you're writing a program. Again, this is really called Mapper. So maybe I should change these slides to write the real name on. So you're writing Mapper. Mapper is going to make function calls to EasyGL. EasyGL makes function calls to GTK, the underlying graphics library, and eventually those calls talk to the hardware. So kind of clear how this could work for drawing. Your program is making calls through a bunch of layers that eventually turn into pixels on the screen. It's kind of like how you do output to a terminal. You send data to see out with member function calls. So your program's in control and sending output. It's a little less clear, how does this work when the user is sending input? So a person resizes the window, or maybe they click on a button in your graphics. So the hardware actually gets that information. So you learned this in 241. Pressing a button, it actually triggers an interrupt, and you can get that information from the hardware. That's passed from the hardware through an interrupt up to the GTK library. So it knows that there's been an event, a user action, but it doesn't know what to do with it. So the hardware is told GTK there's a user action. GTK actually tells our layer, EasyGL, that there's a user action. What is your program going to do? Like EasyGL doesn't know what you might want to do with this user action. So how does it call your program to have you do something appropriate with this mouse click? Okay, so the way that that happens is with something called callbacks. Okay, so when you are configuring the graphics, when you're setting up your window, you register callback functions for various events. So an event, once again, is the user did something. Click the mouse, type something on the keyboard, and the hardware gets that, and it's going to pass that back up to these layers. Going to have interrupts to GTK, and then GTK can pass the information to EasyGL. To get your program to do whatever's appropriate, because EasyGL can't possibly know what you want the person to do when they click the mouse in a certain spot on the window. It has no idea. So when you hand control to EasyGL, which is what you do when you set up the window by making a call to a member function called application.run, is before you do that, you set up some functions that are called callbacks, and you tell EasyGL about them. So when certain things happen, when a user has an event, EasyGL will call the appropriate callback, the function that you've previously said, if the user clicks the mouse on my map, I want you to call this function, and now my program will do the right thing. Okay? And yeah, so Isidore is exactly right. How is this done? You pass a function pointer. And you probably have not done this before. So but it's common as you get into more sophisticated coding and as you get into particularly event-driven programming, where you have to respond to all sorts of user interactions. Okay, so let's look at concretely how do you do this. To open the graphics window, you're going to do this in draw map. So we've already told you EC297 exercise calls draw map, expecting that that will open up the graphics. So this is where that's where you're going to write this code. And the first bit of code, you're just not going to change. You're going to create a settings object, and you're going to say that the window layout is in a file we've already created for you called main UI. We're going to say that the name of the window is main window, the name of the big drawing area is main canvas. You're just going to keep all that because we have set up a UI layout for you, and you should at least start off by using it. And then you basically create an EasyGL application object. So that's the main object that encapsulates this whole graphics library. And you pass it the settings object that you just created. And right here, I'm doing one more thing. I'm creating a rectangle. Okay, so it's a type called EasyGL rectangle. Just a box, two corners, a lower corner and an upper corner. And the two corners that I've chosen are 0, 0 to 1100, 1150 in this case. Okay, so this is 0, 0, and this is 1100, 1150. And that was all setup code. Now I am going to call another member function called add canvas. It's a member function of the EasyGL application. The UI layout we gave you calls the main drawing area we're going to draw your map main canvas. So you're just going to say, I'm going to tell you something about main canvas. I'm telling you two things about it. The first thing I'm going to tell you is what coordinate system I want to use to draw on it. And I have basically already set up this rectangle that I've called initial world. I'm passing that into this add canvas function. So this is saying, what is the coordinate system I want to use? My coordinate system that I've chosen goes from 0, 0 to x equals 1100, y equals 1150. The other thing I'm going to tell you is the name of some function. So this could be anything, but I've chosen the name draw main canvas, which will redraw the main window, okay, the area where you're drawing your map. So whenever something happens, the user resizes the window, the user clicks on zoom in or zoom out, the user uses the mouse functions to zoom in or zoom out, and you need to redraw, you're going to call this function. That's the function that's going to do it for you. Okay? And if you've got any questions, just type them in the chat. Okay, so that's almost all my setup. I just need one more function call, and I'm going to have a window on the screen. So this is still in draw map. I call this member function. So still using my application object, I call the run member function. And the run member function takes 4 arguments. And those 4 arguments are all function pointers. They're all callbacks. So just like this one was. Draw main canvas was a callback. These are 4 callbacks. So they're the names of functions. Initial setup is called as soon as the window is created. So this lets you put some additional setup code in if you want to. Act on mouse press, so the second callback here, is called whenever the user clicks any mouse button in kind of the main part of the window where you're drawing your map. Act on mouse move is called whenever the user moves the mouse within that region. Act on key press is called whenever they press some key, any key on the keyboard, and they're in that kind of main drawing area in your window. Now, if you don't need some of these callbacks, you don't want to write them. So let's say, for example, I don't care if the user is moving the mouse around. I'm not going to do anything. You can just pass in null pointer. And that says there is no callback. I don't care if the user is moving the mouse madly over my graphics window. I'm not going to do anything anyway. So I'll just pass you null pointer. So you can do that if you like. Are you restricted to 4 arguments or is it variadic? Only 4 arguments. So you take exactly 4 callbacks to this application.run. And there was another callback, and this one's not optional, which is your redrawing function. So you must pass in a redrawing function when you do this add canvas. Okay. You're going to see later there are ways that this still allows you to customize your UIs a lot. So I see someone saying, does this lead you to be like B2B collaborate? No, you can actually customize your UI a lot. So we can't react to scroll wheel events. That's a good question. Scroll wheel events, I don't think are passed to you right now. If you want to react to those, EasyGL gets them. We actually intercept them and use them to mean zooming. So EasyGL intercepts certain events and just handles them itself. Mouse scroll wheel, we intercept and treat as zooming events. If you didn't like that, if you wanted to do something else, you can go in and edit the EasyGL source code. Does that make sense? But the scroll wheel actually does something useful. It actually zooms in and out. It's just EasyGL does it for you. You don't actually have to capture those events. Okay, do you have to implement these functions? You have to either implement these functions or you should pass in null pointer. Okay, so if you go, I don't want to do anything if the user hits the keyboard in my main graphics area, then you could just pass in null pointer. If you're going to pass a callback in, well, when the user hits the key, that function is going to get called. So yes, you have to implement that function. Otherwise, it won't compile. And if you just, yes, you have to implement the function if you pass it in as a callback. Otherwise, it won't compile. Does that make sense? Is there a way to have a callback that is called over and over again at a specified frequency? Not with this interface. You could write additional code to do that if you want, but you're going to have to write your own code to set that up. Okay, so what does all this do? So we've given you an example application with EasyGL, and I'm going to go and run this in a few minutes. You should download that from the EasyGL Quick Start Guide and compile it and run it because it's a good form of documentation. So EasyGL actually creates and manages these buttons on the right. It didn't actually create, well, this test button we asked it to create. That's not there by default, but we asked it to create an extra button in this example application. And EasyGL manages these buttons. Well, except the test one, which we asked it to create, and we're going to hook an extra callback up to it. The other buttons, zoom in, zoom out, zoom fit, proceed, these arrow keys, it creates without us doing anything, and it will manage them to handle zooming and panning. Let's see. Application.run, which was the last call we made to bring up this window, will only return when you press proceed. So proceed means I want to close down this whole graphical interface and go on to whatever's next, which might be the end of my program, or maybe I want to do something else. But you'll stay here until you press proceed. Let's see. This is your main window. This whole big red area that I've outlined, that's where draw main canvas draws. So yeah, that's where your drawing callback goes. And I'm showing a bunch of different drawing primitives here. So you can see that we're drawing some polygons and we're drawing, so that's over here. We can draw them in different colors and we can make them partially transparent. This green one is partially transparent. We can draw lines with different styles, different colors, different widths. So these are width 6 pixels. These are width 1 pixel. You can draw text at different sizes. You can draw, let's see, these are just more polygons. You can draw arcs. Okay, so that's drawing arcs, and these are filled arcs. And you can draw images. Okay, so that little star is a PNG image. So it's a little picture that we downloaded from somewhere. And you can basically draw any PNG image that you can get. You can load that into EasyGL with one function call, and then you can draw it all over the place. So you can draw little bitmaps as well. All right, so hopefully that's clear. Do we need to edit main.ui if we want to add buttons? If you want to add buttons over here, you don't have to. Okay, just one function call in EasyGL will add this button for you. If you want to add, maybe buttons over here or some kind of completely different user interface element, because there are other things besides buttons, then you have to go and edit main.ui using a tool called Glade. And we'll talk about the EasyGL Quick Start Guide talks about that, and we'll talk about it in the tutorial next week as well a little bit. but you don't have to do that if you don't want to. That would be considered an extra feature if you decide that you're going to make additional user interface elements, over somewhere in this part of your display using Glade. Okay, so hopefully that's reasonably clear. Let me quickly stop screen sharing from this computer and share on a different computer. All right. Let's see. It looks like you guys can see my screen there. So, and I was making sure I started recording. Yeah, okay, I'm recording. That's good. Okay, so I'm just going to look through the basic application code quickly here. Let me make this a bit bigger. This is the EasyGL examples program that I talked about. So these are a bunch of different function definitions. Okay, here's the main program. So it just does what I just showed you. Okay, this is setting up those settings and some sort of boilerplate code, setting up an initial coordinate system. And I showed you the coordinate system we're going to use. In this case, we're going from 00 to 1100, 1150. And then we call this application.run. And we're passing in 4 callbacks in this case. One for the mouse, mouse button press, mouse movement, and keyboard presses. Okay, so that's all the setup. The most important function is our redrawing function, which we go back up here. That's where, remember, I connected here. I pass it in to this add canvas function. I'm registering my callback. Passing a function might seem strange, but you've just learned in EC243, I think it's the branch link instruction in ARM, which basically lets you call a function. All that instruction does is it goes to a certain memory address and starts fetching instructions from there. So it just changes your program counter to go to that memory address. So all this means is we're passing the address of the in memory. So where does this function start in memory? It's being passed to this member function, add canvas. And that's all we need to know. In order to call a function, you just need to know where are its instructions located in memory. So when application needs to call for a redraw, you've actually told it, go to the function at the memory address that I've given you here, because the compiler actually figures out, well, what memory address is that? And that's what it passes. So then it calls it. The callback must match the function signature. Okay, so the function signature for draw main canvas, which was defined by EasyGL when we wrote it, is I return a void, so nothing, and I take one argument, which is a pointer to an EasyGL renderer, an object that allows me to draw. You cannot change this, okay? Because the redrawing callback, all that's getting passed into EasyGL is the address of the function that you want. And then EasyGL is going to assume that that function takes this input and returns nothing. If you break that assumption, bad things will happen. Well, first, it won't compile. Okay, so you can name your callbacks anything, and then you just pass them in to register them, but they must have the right signature, meaning the right inputs and outputs. And if you don't do that, you'll get a compiler error. Okay. I see a question from Mark. Where is G passed in? G is passed in by EasyGL, right? So remember, EasyGL is actually going to be calling your callbacks. So when it calls your callbacks, it will actually pass whatever data it's supposed to pass. So because the function is supposed to take a renderer, when EasyGL calls it, it's going to pass it a pointer to a renderer. All right. You don't do that. EasyGL does that. You just tell it the name of the function that it's supposed to call for a redraw. All right. Here's my draw main canvas. And it's going to draw the graphics that I just showed you. Some examples of rectangles, arcs, text, etc., polygons, all sorts of different stuff. Your redraw function in milestone 2 is going to draw your map. And those functions can get very long very fast, so you should use helper functions. And that's what we've done here. So we've got a whole bunch of helper functions that actually do the drawing. All right? And you should go through these. This first one here is drawing a bunch of rectangles. So it basically sets some colors, draws some text, etc. So it's going through a bunch of the drawing primitive calls. All right, so let me run this so you can see what it does. All right, so I just ran this, and uh, let me just interactively show you what's going on. So as I click on zoom in and zoom out, and if I have a mouse with a scroll wheel, I can just do this by scrolling the scroll wheel. You see the graphics are changing. If you look through the draw main canvas that's there, you'll see that it doesn't do anything to make that zooming work. All right, EasyGL is just changing how it maps from the drawing calls that you're making in your coordinate system to the screen, and that's what's making it redraw in different ways. Uh, you can also see that, yeah, I've got some transparent things and some non-transparent things and so on. One last thing is, you see this box in the top left is not moving as I pan and zoom. So other graphics are moving around, getting bigger, getting smaller, but what's up here is not changing. All right. So I'm going to show you how that works a little later in the lecture. But basically, we have two different coordinate systems, and the main coordinate system you're going to use is called world coordinates, and those are basically going to automatically be zoomed, panned, etc. But if you want to draw something in a fixed location, you can also draw it in what's called screen coordinates, and those will never move. They'll draw it at certain pixels. Let's see. There's You can also do animation. So if you go through this example program, you'll see that this is just animating with no input from me. So it just drew all those lines. And now if I redraw, it'll go away. Here's an extra. And basically what's happening over here on the side is we're printing out what's going on. Okay, so the mouse move callback that we passed in just prints where the mouse is. So as I move my mouse over, you'll see that there's all these output coming because my mouse move callback is just printing where's the mouse. If I click the mouse, you see that basically a different callback was called, the mouse click callback, and it just says you click the left mouse button at this coordinate. Now I just click the right mouse button. Now I just did, I clicked with shift left, and so on. And the last key callback we defined was for the keyboard, and it's just going to tell me what keys I pressed. Okay. The coordinates that it passes, I see a question. Does it give you coordinates relative to the zoom level? The coordinates giving to me are world coordinates. So I said I wanted my coordinate system to go from 0, 0 to 11, 1, I think 1100, 1150. That's the coordinate system that it passes back mouse locations in. And yeah, it understands the zoom. I've zoomed in on a certain part of my coordinate system. So you'll notice that I can't get all the way to 0. And the reason I can't get all the way to 0 is already zoomed in some. If I zoom in more, you're going to see that the coordinates are all now in a relatively narrow range, right? Between about 400 and 600. When I go back out, the coordinates are bigger. I can go all the way to some negative coordinates and all the way to 1200 or so. Let's see, there's a question, is there a way to access the current bounds of the screen? Yeah, there's a function in EasyGL to ask what is the current pixel boundaries of the screen. You don't need it very much because the vast majority of your drawing, maybe all your drawing, you're going to want to draw in world coordinates, so the coordinate system you defined. And in that coordinate system, you don't really care how big the screen is because it's not your problem. It's EasyGL's problem. All right, so let me just stop that for a second. And let me add this draw main canvas. Let's just put in one more piece of code here. Let's just say, okay, so let's say we do that. So I want to make this tell me when I draw. The other thing I want to do is, let's say that well, maybe I'll do this in a minute. Okay, so let me go back to my other computer, and we'll come back to this in a minute after I've shown you a few drawing functions. Okay, so if we can see the other computer now. Okay, so that was the example program. So you should run it. You should look at it, see how it works. It's pretty good documentation. So the draw main canvas callback is the most important one. And as I just told you, it takes one argument, a renderer, and use that renderer object to access all the drawing calls in EasyGL. And there are things like setting the color. So I can say set color, and I can set it to a predefined constant. So this is defined in the EasyGL headers, but there's a predefined black. So I could just use that name. Or if I want a wider variety of colors, I can pass in four numbers: red, green, and blue in 8-bit values, so between 0 and 255, and alpha. Alpha is transparency. So an alpha of 255 means opaque, and alpha of 0 means transparent, and in between means partially transparent. If you don't pass in the fourth argument, so if I just passed in 3, that's allowed, and you'll just get opaque drawing. It'll default to 255 alpha. Opaque is actually faster. The graphics hardware has less work to do because it doesn't have to read the old values of the color of the pixel and then blend in a new value. So if you don't need transparency, it is faster to not use it. But when you want it, it's not that much slower. It's on the order of 2 or 3 times slower. You can set different line widths. So here I've said I want a line that's 3 pixels wide. 0 pixel is really fast. So what does 0 pixel really mean? 0 pixel really means 1 pixel. But it means you can be a little bit sloppy about how you draw it. And it turns out that it's about 100 times faster than drawing other lines. So if you want just a thin line and you're not too concerned about exactly how thin, then setting the line width to 0 is going to be faster. You're not going to be able to do that for everything because it'll just look bad. You can set dashed lines, and there are a whole bunch of other attributes for like text size and so on. All of these attributes in EasyGL are sticky. What that means is that they stay until you change them. I see a question, what's the default line width? The default line width is 0. Okay, so that's what we start with because it's fastest. Once you've set the attributes you want, you draw primitives. So I can do things like draw a line between 2 points. I can fill a rectangle, so that's going to draw a filled in rectangle between 2 points, and a whole bunch of other things. You just saw a bunch of them in that EasyGL example program. Okay, so let's try something. Quickly go back to that example program and we'll change it. So I want to draw a thick, dark blue diagonal line across the middle of the screen, and I want it to go on top of the other graphics. Okay, so how would I do that? Let me stop sharing on this computer and share on the other one where I have something running. Okay, so I'm back in my program. Is there any difference between a thick line versus a rectangle? There are not much. I mean, you can also change the style of the end of lines. So lines can actually be drawn with rounded ends if they're bigger. So in some cases, they can be different than a thick line might be different than a rectangle. In some cases, it might look identical and you can just decide what you want to draw. Okay, so first question, I want to draw my thick, dark blue diagonal line. And I want to draw it on top of the other graphics. So where do I put the code? That's the first question. Do I put it up here? Right? This is my main function. It's setting up my window. Where do I put it? I think I'm still recording, Ken. Let's see. Yeah, I think it's recording.
Okay, good. I'm just making sure. Thanks.
Yeah, okay. So Trevor's saying put it inside the draw main canvas callback, and that's right. So I have to let EasyGL call me in order to actually draw. So I got to put it in the callback. I want to put it in my screen redrawing callback. I want it to go on top of the other graphics. That means order matters. I need to put it at the end of this callback, not at the start. If I put it at the start of the callback, all the other graphics are going to draw on top of it. I don't want that. I put it at the end. Okay, so yeah, we figured out where to put it. What am I going to call? I've got this renderer G. Okay, so G is a pointer. And if I go G dash, I actually see all sorts of options. You know, what functions might I want to call? And actually I can see even help on some of them, right? Um, let's see. You want to set the color and thickness. Yeah. So the sets start with set underscore. So you can see there are a bunch of set color calls, and you can actually click on them and it'll show you help. So this set color call says it takes a red, green, blue, and an alpha. And so EasyGL is heavily commented, and it's commented in a way where NetBeans picks up the comments and tells you about them. So it helps you when you edit this in NetBeans. All right, so on set color, RGB. What should red, green, blue be to get dark blue? This one's not that hard. So what should the red be? Right, so 0 for the red, 0 for the green, 255 for the blue would give me bright blue. So I'm going to actually go, if I want dark blue, let's say I'll do 120. And I don't want it to be transparent, so I'm just going to leave the last argument out. I want it to be a thick line, so I can use set line width for that. Okay, I don't want it to be dashed, so I'm not going to bother with that. I don't care whether it rounds the end, so I'm just going to do set line width. I want it pretty thick. Let's say I want it 20 pixels thick. Let's see what that looks like. Okay, that was all setting it up. Now I actually need to draw something. Okay, so all the drawing functions start with draw. So I don't want to draw an arc. I want to draw a line. Okay, and the line takes 2 points. And it's in the coordinate system that I've defined. So if I want to go from the bottom left, what's the bottom left of my coordinate system? Yeah, so I can go from 0, 0. That was my bottom left. And you might not remember this, but the top of the coordinate system was, it was actually 1100, 1150. I'll just go 1100, 1100. So that'll be around the top of my coordinate system. And the other thing I did is I actually put in a little bit of output so that we can see when the redraw is called. So let's build this. Okay, so it's built. Let's run it. And I do indeed have a big diagonal blue line. And it goes from bottom to top, so it all looks good. If I zoom in or pan, you can see my line moves around, and I didn't write any code to do that, right? So zooming all just works. Let's see, what else do I want to show you? So this redraw function, if I resize the window, you'll see that the redraw just got called a bunch of times. Okay, I'm resizing some more. Let's move that so you can see. Now, if I zoom in, let's see what happens. I zoom in, the redraw was called. I zoom out, the redraw was called. I zoom fit, the redraw was called. So EasyGL doesn't know how to draw your graphics. It's just calling your redraw function at the right time. Okay. Yeah, EasyGL includes drawLine. DrawLine is part of EasyGL. Okay, so all those functions that you saw when I typed G dash, that's all part of EasyGL. And I see a question, is there a function to reset everything to default? No, we didn't make a function to reset everything to default. So if you change some properties and you want to be sure you know what they are, you should just change them back. Okay, so let me stop sharing that and go back and share from this screen again. Okay, so let me keep going. Okay, so we just talked about some of these callbacks. Well, the screen redrawing one, that's the most important one. There's another one that takes this function signature. It in the example program we call it act on mouse button, but you can call it anything you want. It takes a pointer to the EasyGL application. It takes a pointer to some information about the event, what was pushed, which you can look at if you want, but you don't have to. And it takes the coordinates where the mouse button click happened. So if I write this function, I could basically output the mouse was pressed at a certain XY, and it tells me where did the user click, and the coordinate system is the world coordinate system. So it's the coordinate system that I defined. That's what it's going to tell me. If I wanted to know some more information, like what button was it, well, I can look inside this data structure. So there's a button field in there, for example, and that'll tell me which button was pressed. Once again, this callback has to have this function signature. EasyGL is going to call it with these inputs. It will not work if you don't use this function signature. So even if you don't want to use some of these parameters, when you define the function, this is the set of inputs that you have to define it to have. Okay, so let's talk a little more about coordinate systems. So GTK, the lower level library that EasyGL is built on top of, uses pixel coordinates. And in computer graphics, for kind of reasons that I don't know, they define pixel 00 to actually be the top left, not the bottom left, but the top left. So on a certain screen and a certain window size, these might be my coordinates from 00 to pixel 900, 619. And that's actually what GTK uses, pixels, starting from the top left. Okay, so how many pixels should you draw for certain objects? So let's say I'm drawing a polygon for Grenadier Pond in High Park. So that's down there. Um, in milestone 1, we show you how to go from the latitude and longitude data that OSM provides to XY points on the Earth's surface. So that would be a good way to figure out what the points you want to draw are. Let's figure out where they are physically. Let's project them to XY. But in GTK, that's not enough. We would now still need to convert them into pixels. And that's going to involve some kind of transformation, figuring out how zoomed in we are, how big our window is, and so on. And you don't really want to scatter that transformation through your code. It's going to be a big mess. So what we do instead in EasyGL is we define what's called a world coordinate system. That's a common term in computer graphics. And it's basically a coordinate system that you choose. So for example, we could use our coordinate system could be essentially XY coordinates on the Earth that come out of the milestone 1 projection. The milestone 1 projection basically gets distances in meters from the prime meridian and the equator. That's what the functions in milestone 1 are actually computing. So for Toronto, I could find the bounds of those XY coordinates across the whole map of Toronto, and I could set my initial world, my coordinate system, to kind of span just those. Okay? So the initial world for Toronto, after I've done all this projection to XY, would be from about negative 2000 exponent 3. That's my X, and Y is some other number, some other big number, to X equals negative 1950 exponent 3, and Y is another big number. Okay? So there's nothing magic about these numbers. They're like meters, and I found a bounding box in meters around Toronto, and I just said, that's my coordinate system. Don't ask me why, it's just convenient. Okay, so that might define this coordinate system from X low, Y low to X high, Y high. That's the box. EasyGL knows that you probably don't want to distort your drawing. So if your window doesn't match that aspect ratio, so in this case, the bounding box I got for Toronto is not actually the same shape as my window. So EasyGL will basically expand the vertical dimension. It'll give you some extra. You'll have some extra part of your world that's visible. So the unit in the X direction is the same as a unit in the Y direction. Your graphics aren't distorted. So that all happens for you automatically. Okay, so this might be the initial coordinate system that's actually visible on the screen, which is a little taller than what you asked for, but it gives you exactly the X span that you wanted and doesn't distort anything. Okay, so one of the things that does for you is you no longer need to worry about how do I turn Grenadier Pond into pixels, and also this is how the panning and zooming works in EasyGL. As you click the zoom in buttons, the zoom out buttons, the left and right, or use the mouse scroll bar or scroll wheel, what EasyGL is actually doing is it internally has something called a transformation matrix, which is the mathematical relations that it's using to translate from your world coordinate system to actual pixels on the screen. And it just updates how that scaling occurs as you do panning and zooming. So if you said I want to zoom in a bunch, EasyGL would figure out, well, you want to zoom in, so now you only want this much of your world coordinate system visible, a smaller fraction of it. Maybe instead of from negative 2000 to negative 1900, you only want from negative 1990 to negative 1960 visible. So it updates its internal transformation matrix, it's scaling, and then it just calls your redraw function again. And your redraw function just does the same thing it did before. It says, we'll draw all the streets in Toronto in the coordinate system that I asked for. And what'll happen is only part of it shows up on the screen. So you'll now see a zoomed in view. So if I go back here, one screen ago, you can see more of Toronto and the Grenadier Pond is smaller. After the zooming, you see less of Toronto and Grenadier Pond is bigger. But you didn't have to change anything in your code. You did the same redraw you always did. All that happened is EasyGL changed how it mapped from your world coordinates to pixels so that you zoomed in. Um, Hopefully that makes sense to everybody. Okay, so what does this mean? It means your draw main canvas callback can always draw the whole map, and only the proper part will show up on the screen, so you get panning and zooming for free. People ask me sometimes, does this take a long time? There's some CPU time to draw objects that aren't on the screen, but it's less than you might expect. EasyGL checks if things are off screen before it does any other work, so it pre-clips them and it's fast. So it's not too much extra work. Sometimes you might say, well, I might have something I don't want to move around. So let's say, for example, and so basically, there are also screen coordinates in EasyGL. And those what we call screen coordinates are pixels. So they start at 0, 0 in the top left, and they go to basically the size of the window in the bottom right, or the size of the area that you would draw in the bottom right. So you can use that to draw things at a certain point in your window. So let's say I want a legend. I want to basically show how big a kilometer is. And I always want that to be in the upper left part of my screen. I don't want it to move. I don't want it to be resized as we pan and zoom. You can ask EasyGL, you say, I want to draw in the screen coordinate system. So set coordinate system screen. I'm going to do some drawing. I might draw some text, draw some lines to make this legend. And then when I'm done, I can say, okay, set my coordinate system back to world, which is the coordinate system that I asked for originally, matches my map, and will pan and zoom. Okay. So another thing you need to think about is level of detail. So if you're zoomed way in, you can show small details. You can show small streets, you can show the names of streets, etc. But if you're zoomed way out and you draw everything, all the little streets, all the names of everything, you're just going to see, a mess or maybe just a black box. So you need to figure out some ways to turn off detail as you zoom out. And that's one of your challenges in Milestone 2. There are a few utilities we give you to make this easier. So let's talk about drawing text. So when you draw text, you ask for a size. So maybe I want 10-point font, and a point is 1/72 of an inch high. So this is asking for text that is 10/72 of an inch high. And notice that that's kind of not scalable. That's like a certain amount of screen real estate. And I might say, okay, I want to draw at centered on a certain point, the text awesome street in that point size. Okay. So maybe I'm zoomed way out. So the street I'm drawing is really small. And therefore, the text that I put on top of it is actually a lot bigger than the street because the text is it's not scaling as I zoom in and out. Okay, so if you do that for a lot of streets, this might look really messy. All right, so something that's an easy technique to make this look nicer is EasyGL has 2 extra optional parameters. When you call draw text, you have 2 mandatory parameters. You have to say where do I draw it, and by default it's centered at that point, but you can change that. And what is the string? What's the text? And then it has 2 optional parameters, which are basically don't draw the text if it's going to be bigger than this in world coordinates. So they're optional and they default to huge values, which means always draw it. But if I basically said, well, I don't want my street to be drawn if it's more than 0.2, and maybe in my coordinate system that means 200 meters long. So if the text is going to be more than 0.2 units in world coordinates, don't draw it because I know that that's going to be too big for the street I'm putting it on. I can make that happen by just passing that bounding parameter into draw text. And now draw text will draw the text if it's going to fit in basically a box of this size in world coordinates. And if it won't fit in that box, which means maybe I'm worried it's going to obscure other things, it just won't draw it. So that's one easy level of detail enhancement you can do. All right, and that would make, as you zoom out, your display just naturally gets cleaned up. And the last thing I'll talk about is another level of detailed utility is you can make this, you can call a function called getVisibleWorld. This is another EasyGL function. It returns a rectangle. So a rectangle in EasyGL is just 2 points, lower left and top right. And it returns the world coordinates. So in your coordinate system, where are the screen edges? So we asked for a coordinate system initially that went from 0, 0 in my example to 1100, 1150. So if this returned values of 0, 0 to 1100, 1150, you would say I'm pretty zoomed out. If this call returned values of 1 comma 2 to 2 comma 3, then I'm zoomed way in. And you can make decisions based on that about should I draw lots of things or not too many things. And I'm not going to talk, we'll talk next week briefly about the next topic, which is how do we figure out what a person clicked on. So I think we'll end it there today because I think it's getting very close to your midterm. And good luck on the midterm.